Okay, this is a quick overview on electron configuration. Just a quick reminder of what an atom looks like and where the subatomic particles are. We have a nucleus, and inside that nucleus we have our protons and our neutrons. Protons being the defining characteristic, or the number of protons being the defining characteristic of the element. And then on the outside we have electrons. Now, in the past, we've given these orbits, okay, these little circles that are surrounding the nucleus, kind of like planets revolving around the sun. But in truth, this being the Bohr model, okay, this is not an accurate representation of the atomic structure. Okay, modern atomic theory is supposed to show that there is not a fixed position of the electron, but more of a probability that electron can be in a certain spot. And the places that it can be is called the electron cloud. Okay, so within an electron cloud, you have our electrons, and then inside you have the nucleus, which has protons and neutrons. Okay, so it's a quick overview. This is what our model was before, with the Bohr model with an orbiting electron, but now it's not so much an orbital, but hey, here's an electron right here, and there's a certain probability that it could be represented at this particular point. At other times it could be over here, at other times it could be over here. It all depends, of course, on the energy of that electron. So the different, I guess we could say, different types of levels or different types of spaces that an electron can exist, which we will call orbitals. Okay, there are 4 different types of orbitals. Okay, we have s orbitals, p orbitals, d orbitals, and f orbitals. Okay, I'm not going to have you guys go into specifics as to what they are. In fact, we will probably not even touch these 2 guys right here. We're going to concentrate on the s orbital, or the s block, and the p block, and in doing so, determining the electron configuration. Okay, this is what is expected of you. You need to know the electron configuration for elements 1 through 20, which is hydrogen through calcium. Okay, so let's go ahead and take a look at what these different blocks look like. Okay, so as we can see right here, the first 2 the first 2 groups, that is the S block. Okay, the transition metals, that's the D block. The lanthanide and actinide series, those are your F block. Okay. Okay, your F block's down here. F. This is your D block. This is your S block. Okay, so D block. And then over here we have, which consists of the metalloids, nonmetals, and some poor metals. This is your P block. Okay. Now, if you notice over here, there's one s orbital that's, or one s that's way over here, this s orbital. In fact, just because it's arranged like this on the periodic table, in truth, it is more likely to be right there. It's just they put it over here to indicate that it is, you know, when we see it on the periodic table, we see helium, which is this right here. We see helium that's over on this side, but in fact, it is of the s orbital, or the s block. Okay, so this is your S block, okay, right here. This is your P block, and those are the only ones that you're really dealing with. You're not going to worry about the D block or the F block. Now, when writing electron configurations for an element, let's go ahead and say carbon. What we need to do is we need to indicate which blocks each electrons are in, because carbon has 6 electrons, okay? But we can actually indicate where those electrons are and the different types of blocks they could be found in. So looking at carbon with its 6 electrons, okay, this S block right here, right? S block, and then this is also S block. This would be 1s, okay, and then there's one electron in hydrogen, so 1s1. This would be 1s2. Now, since I have a full period right there, when I write down the electron configuration for something like carbon, I would write down the noble gas configuration, the last one within that period. So the electron configuration for carbon would start out as 1s1, and then you see right here, this is my second. Okay, once I go from helium, I go over to lithium over here. Okay, now this right here is the 2s block, okay, or the 2s orbital. And since I have one electron, two electrons, that's 2s2, so it would be 2s2. And then here, this is my 2p block. But thing is, I didn't go all the way to the end. I'm only going to go 1, 2. So it would be 2p2. That would be the electron configuration for carbon. Okay, we'll do a couple more so you guys can see how we do it. Okay. Boron. Okay. Actually, let's go ahead and do start off with what we have, which would be, or start off with what we need to look at, which would be boron, which is this guy right here. Right? So let's take a look. We have 1s1, then we have 1s2. So I would start off with boron. Boron would start off as 1s2. And then here's my second S, 2s2. And the reason why there's 2 is because it's representing these two electrons. There's an electron here, and then there's an electron here. And then boron, which would be, and this is in the p orbital, 2p, and since there's only 1, 2p1. 2p1. Okay, we look at sulfur. Okay, let's go ahead and erase this real quick. Sulfur, we have again 1s2. We have right here 2s2. Now sulfur is down here, which means I'm going to fill up this whole block, and I'm going to mention this whole block, which would be 2p, 1, 2, 3, 4, 5, 6, 2p6. And then I'll come over here. Now this is, just like this is the first row, this is the second row, this is the third row. This is 3s2, because I have 1, 2. Just like I have 1, 2 here. And I have 1, 2 there. This would be my 3p orbital. And I would go 1, 2, 3, 4. So 3p4. So if I was to draw the electron configuration for sulfur, it would look like this: 1s2, 2s2, 2p6, excuse me, 3s2, 3p4. And that would be the electron configuration for sulfur. Okay, I want you to go ahead and try to do calcium. Okay, go ahead and pause the video, give it a shot, and then I'll give you the answer, and we'll work it out. Okay, so looking here. Okay, here is calcium right here. So we're going to go into the 1, 2, 3, 4th row. Okay, so let's go ahead and take a look at our orbitals. This right here, which, like I said, would consider helium, that is 1s2. This one right here, 2s2. 2p6. 3s2. 3p6. And then here, this is my 4s right here. 1, 2, 4s2. So when I do the electron configuration, it'll look like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay? So, it should be noted that you can shorten this up. There's the long electron configuration, and then there's also the shorter electron configuration. Okay? What you would need to see is, like, for example, let's take a look at sulfur. Okay? Well, when I look at sulfur right here, I can use the most recent noble gas as a shortcut, because if I indicate that neon, like so, I can do this. This right here is neon. And if I wanted to shorten things up, instead of having to write out everything that would get us to neon, I can just do neon, and I put in brackets, and then I'd go 3s2, 3p4. Okay? It's the same thing. This one I wrote in blue and the one I wrote in black, they mean the same thing. And I'll go into more detail with the shortcut in class.